Sweet. So we're up at Hacker Expo. Welcome back, everybody. Let's get started with our live judges. So if you are currently waiting to be added as a moderator for your booth in the Hacker Expo, our team is working hard to fix that. So sorry about the delay. But in the meantime, and throughout the expo through 3 o'clock, hopefully we'll still finish on time. We're going to be bringing teams on to do live project demos. So without further ado, I'm going to bring on Irene, who's going to introduce the first team. And actually, before we do that, let's have the judges all come around and introduce themselves. So Keith, would you like to go first?
Sure. I'm excited to be here. I'm Keith Worley. I'm professor of the practice and the managing director of the Business Analytics Center at, hang on. Oh, sorry, I'm getting an echo here. Hold on. I'm the managing director of the Business Analytics Center at Scheller College of Business, and we work with the MBAs in Business Analytics, undergrad students, and the MSA program. So hopefully we have a few represented here. So thank you for having me. I'm excited to see the projects.
We're super glad to have you. Charles, why don't you go next?
Hi, my name's Charles Lar. I'm the director of data analytics for the Emerson cold chain business. I lead the function, which includes business analytics, as well as our data science team, where we do internal and external analytics for our customers.
We're super glad to have you and Emerson here this weekend. We really appreciate the support as well from Scheller Business Analytics. Yuri.
Hi guys, Yuri Katomsev here, working in Anthem. We're in a cloud engineering team, so we're loading all the data from all over the place and into cloud and Snowflake and other systems. So happy to be here.
Yeah, and we're super glad that you and Anthem are here and helping make Hacklytics possible this year, despite being virtual, and super grateful. So I'm going to bring on Irene, and Irene, she's going to introduce the first team. And the way that this will work, the team will get to introduce themselves, and they have a couple minutes to present their project. If they want to screen share, and if they want to play a video that they made, they can do that. Or if they just want to screen share and talk it through, however they would choose to present, it's kind of up to them. And judges, you guys are free to ask questions, engage further, and at the end, you can pull up your Rocket Judge, and you should, if the team isn't there able to be scored, you should be able to do it pretty soon. So don't worry too much about that. But yeah, okay, let's bring on Irene. And Irene, please take it away.
All right, hello everyone. Thank you for joining us today. I'm going to present our first team, which is Project Hail Mary.
Hello everyone.
Hey everyone.
Hello.
My name is Mark.
My name's Tilo.
My name's Zach.
And our project was Hail Mary. Mark, you want to go over a brief description?
Yeah, so we were kind of inspired for this hackathon. It's Super Bowl Sunday, so we decided that we wanted to do something football related, and we kind of wanted to create a statistical way of predicting the final score of the Super Bowl. That was the initial goal coming in. And so to do that, we knew that we had to use a lot of data, and we had to create a neural network that could take inputs and predict the final score of a football game. And so we used data from Pro Football Reference, as well as a couple other sources, and we cleaned it up, and we created this neural network. And one of the byproduct features, the original goal was to predict the Super Bowl score, but one of these byproduct features that we thought was pretty cool was, because we were using data from different years across since 2013 all the way until this season, we are actually able to use the neural network to predict scores between teams that have never played before. So you could take the 2015-16 Patriots and put them up against this year's Chiefs, and you can see, using the neural network, what that final score would be. And so Tilo's going to share his screen in a second. We can kind of see how that works and what that looks like.
Okay, give me 1 second. Are y'all able to see that?
Oh, there it is.
Yeah, we can see it.
Awesome. So I'm going to go through a couple examples just to kind of show you how the website works. So for example, we'll take a very dominant team. So if we look at this season's Kansas City Chiefs, obviously in the Super Bowl, we'll take the 2016-17 Browns. They're completely defeated season.
Yeah.
When we feed this into the neural network, we get, Kansas City Chiefs winning by 34-19 with a confidence of about 87.8. So that's something that we would, definitely expect if you were to kind of just logically think about the performance of these two teams. Now, like Mark said, a really cool byproduct of using data from different years is being able to compare different eras of the same team. So we can actually compare, the season's Cowboys amidst all the quarterback and position turnovers with the 2018-2019 Cowboys. And you can see that based on, a number of factors, the 2018-19 Cowboys being, relatively healthy and having a good season, the model is able to predict that they would have a better score to win the game. And yeah, we also did home team and visiting team. So because of some hidden, people always talk about home field advantage. So switching these, you can actually see that the score changes a little bit. For Dallas, it doesn't make sense. They would be in the same stadium, but switching home team versus visiting team could have an influence on, crowd size turnout, just comfort in the stadium in general, and a number of other factors.
Exactly. So we approached a number of challenges in attempting to put this together. For one, we are fairly new to the whole idea of activation functions and neural networks. So, and we also had no experience at all in TensorFlow. This was the first time we've ever used it, and we had to use it both on the back end and the front end. So actually, I'm pretty proud. I think I can speak for the rest of the team here, but we're pretty proud of what we were able to do with TensorFlow and how versatile it seems to be. We put together a series of hidden layers, and we used a lot of we were testing a lot of different activation functions. Took us all night nearly, but we put it together, and we're really proud of what we got here. I will say putting the data in such a way where it could be read was a huge challenge. We ran into a number of difficulties in putting in the data to where it could be put to where it could be read properly. But yeah, so this is sort of what we got going on here. If you have any questions.
And for the big finale, our Super Bowl prediction, according to our neural network, Tilo, if you'll take it away.
Sure thing. So our model will predict a 29-28 score with a 1.4% confidence. So what that tells us is that this Sunday's game is going to be a very good game to watch.
I just want to make note that that's not as helpful as you might think for for those people that have money on the game. Darn it!
Yeah.
What am I supposed to do with 1.4% confidence?
I know. And so, and we can even do this. We can, let's say, since there's technically no real home team at a Super Bowl, we could flip it. They are in Tampa, so there is kind of a home team. But if we flip it, we do get different scores.
Yeah. We can also go into how the confidence interval is kind of created. So we actually have 3 outputs to our neural network. It's not just the 2 scores. We also have an input that's just between 0 and 1, which is basically the win probability, where being closer to 1 means the home team has a higher chance of winning. Closer to 0 means the visiting team has a higher chance of winning. So when the score is really close, that number is very close to 0.5. Like it can't really make a decision on who's going to win. And that's where you get those pretty small confidence intervals.
Yeah. So it probably showed up as 0.542 here, which is why it's so small. But yeah.
Yeah. And that takes into account, during injuries during the game and other factors that just could not be predicted with a machine learning algorithm.
Yeah. The chaos factor.
All right. So questions? Are you taking questions now?
Yes, absolutely.
All right. So one of my first questions is did you back test this? Did you say, okay, over the last couple of years, these were the matchups in, 2019, 2020, and even further back? What did you do to kind of test and do back test and verify, the accuracy?
Yeah. So when we ran the network, we we didn't use all the data to train. So we took about, if I remember right, maybe about 3/4 of the data that we had collected. It was over 8 years worth of games. We took 3/4 of that data, we used it to train the network, and we used the last quarter for validation. So we did validate the data with games that the network had never seen before.
And what was the result?
The validation accuracy peaked at around 0.734.
So about 74%, which, given all the hidden factors that go into football, is pretty
That's
good.
good. Yeah.
Okay.
It's about for every 3 games, we got 2 of them correct. In terms of a binary output between which team won. Yeah. It was pretty accurate.
Very good.
All right. Do we have any more questions regarding this project? No? All right. Thank you so much, everyone, for presenting. We're going to move on to our next project.
Nice job, guys.
Thank you.
Thank you.
So I'll go ahead and move them from the stream. And now we have Hurdle Tracker. Please introduce yourself and present your project. Thank you.
Thank you. My name is Evgeny Seagal. My team is actually currently asleep, so I'm manning the booth for them. And we took up the challenge of tracking athletes jumping over hurdles. And I will share our dev post page in the chat and also give a quick overview. Let me just share my screen. Can everybody see? Can everybody see the shared screen? Thumbs up if you can.
No, not yet.
Interesting. It says that I am sharing the screen.
There we go. It works now.
Oh, cool. Okay. So feel free to check out the video after this. So one of the biggest challenges that we had was, given the limited videos, to come up with a way to measure automatically. And the problem can be split into 2 sub-problems. You have to know the 3-dimensional position of the athlete and the scene in general. For that, you need to automatically infer the camera location relative to the scene, as well as camera properties such as the focal length and distortion. And the other sub-problem is, once you have the 3D coordinates, you have to infer the start and end of the jump. So for the main project, we used OpenCV, and we tried different methods, and one of the methods that worked well for this was the scene subtraction in combination with object tracking. So here on the screen, you can see the original video, the subtracted scene, and we used an OpenCV technique called YOLO to detect the objects. So a 2-dimensional video effectively erases the depth information, but you need depth in order to be able to gauge the precise number of inches of the jump. So in order to do this, this is where the first sub-problem of determining the perspective comes in. On the bottom screen, you can see feature extraction of the ground plane. By assuming that all of the jump stadiums are flat planes with markers on them, we can use that assumption to determine the perspective. One of the simplest ways to do that is, once you have a rectangular area with a vanishing point, you can determine the perspective. At that point, you determine the camera position and then the depth. And once you have the depth, you can also use some cues. For example, we knew from the presentation, from the PowerPoints that were given to us, that this area is 26 inches. There's also standard hurdle heights and width that we can infer. So based on that information, we get our cues to get the precise location. So here we can see in the first video that the jump distance is 94.2 inches. We can also infer the speed based on the frame rate of the video and the camera properties, as well as some other statistics such as position after the line, position before the line. So some of the biggest challenges in these particular videos, the camera is stationary. Most of the research paper out there on camera position actually assumes that the camera is moving. In fact, today you can use augmented reality. Smartphones have extra sensors. So this is actually would be our question to coaches. If you could use a smartphone to film somebody, would that be something that is more convenient or less convenient? So with a smartphone, you could actually measure a lot of things nowadays. In fact, iPhone 12 has a LiDAR even. So it could give you instant real-time three-dimensional position. That's kind of the other thoughts that we had. And I'd like to open for questions.
Okay, thank you for your presentation. Do we have any questions regarding this project?
So Eve, how did you get selected to do the presentation while the rest of them slept? I'm just curious.
we take shifts. We took shifts.
All right, good. So good teamwork, man. Nice presentation. I really am. I'm gonna spend time in the video and look at it a bit more. So I think you guys have done a fantastic job with some dirty data and dirty videos. So these are very different perspectives, very different depths. So one of the things, and I don't think you did this, but what would be kind of the next step? I see a couple of things where you go, oh, geez, could you in that bottom right frame, the black and white one where it's detected the object, actually do kind of stops where the foot hits the ground, and then you can mark it and say, okay, that's that distance. So what they're looking for is, basically from takeoff foot to landing foot, what's that distance, and be able to mark that. Do you think that would be something that could be done directly from this, the work you guys have done?
Yes, and actually that's what we do here. So based on the detected objects, we measure the foot as it leaves the ground, and then the landing foot, and then that distance. Now this gives us pixels, but that's where the whole camera inference comes in. So once you know the perspective and the depth, you can actually measure the inches.
So the idea is that you would be able to, at least on the video, have it actually leave a little mark there, so that as the coach and the athlete are looking at that, they could do it. I do see in this particular video, they're actually jumping over 2 hurdles. Yes. Is it able to record each one of those hurdles as a different line to say, okay, are they being consistent, or are we seeing that at the end of closer to the end of the race, that their gait is changing, or their method is changing, their practice?
So we can detect multiple jumps because we know approximate level that the athlete is running, and so we can infer.
Okay, very good, great job, very neat.
All right. Do we have any more questions? No. Well, then, thank you so much for presenting your amazing work. I really liked
Nice
it.
job.
Yeah.
Thank you.
So next, yeah, I'll go ahead and move you from the stream. Okay. Oh, you did. So next team is Voices of the Vaccine. And welcome everyone. And so please present yourselves and your project. Have a great time.
Hi, everyone. Thanks for having us. We're Voices of the Vaccine, and we are all students at Georgia Tech.
I think, oh, okay. You can see my screen?
Yeah.
Great.
I can't hear you guys.
So I think one of our team members isn't showing up on video, but I think you can hear her audio. So we'll just get started with the introduction. So our project is a sentiment analysis visualization tool that healthcare officials can hopefully use. So we considered a wide number of problems that we wanted to tackle for this project, but when we heard about data science, we first thought about all the information that's available on social media. So we discovered that research findings indicate that certain disinformation campaigns can spread on social media and can actually increase the prevalence of negative tweets about vaccines. So this is a serious issue because if there's a lot of disinformation, then this can actually lead to a decrease in mean vaccination coverage for a certain area because individuals become persuaded to not get vaccinated. So we concluded that there is an urgent need for identifying key geographic areas that have large instances of this type of negative sentiment towards vaccination.
Yeah, so therefore our driving question is, how can we utilize machine learning to create a data visualization tool for healthcare officials to monitor public opinion towards the COVID-19 vaccine?
So I think one of our members can't actually join this presentation, so I'll just cover this part. So first of all, we use natural language processing classification. So we utilized a built-in sentiment analysis tool, which is lexicon-based. It's called Vader, to classify sentiments of a public vaccine tweets data set. So we could establish like a base data set that's actually classified as positive or negative. And then we trained our deep learning model using the public vaccine tweets data set that we already classified. And then we developed a recurrent neural network and trained it using that data set. Then we scraped tweets from Twitter using the Twitter API to collect location and text information from vaccine-related tweets. And then we adjusted the algorithm to increase accuracy and then feed these Twitter scraped tweets into the deep learning algorithm for final sentiment classification. And then we used map visualization in order to create an interactive graph to display this deep learning classified sentiment. So the data set that we used to train the deep learning model contains over 80,000 tweets with marked locations. And this also includes over 56,000 unique Twitter users. All of these tweets that we used to train the deep learning model contain the hashtag COVID vaccine and were collected from August of last year to January 2021. And the data was originally formatted in conventional format.
Okay, so for the deep learning model, we built it with Keras. We first have the input layer, and then we first process it through the encoding layer, which is we refer to as text vectorization, which converts the text to a sequence of token indices. Then an embedding layer stores one vector per word. For this, we use Keras embedding to produce the embedding from our training data set. Then we process the data, the embedding. After the embedding layer, we go through the bidirectional current neural network, which propagates input forwards and backwards for the network, which converts the sequence into a single vector. Then we use two dense layers to do some final processing and convert from this vector representation to a single output layer, an output value, which represents the sentiment value of the tweet.
Yeah, and then we used the Twitter API and TweetD to fetch tweets from Twitter, and we were able to get more than 20,000 tweets that were related to vaccines from the contiguous United States. And these tweets were parsed and grouped by latitude and longitude into a text file, which was fed to the model to determine the sentiment values of each text and also the average sentiment value for each latitude, longitude location. So this is what our website looks like. And there's an interactive graph here that each dot that's plotted shows the sentiment value, the average sentiment value of the tweets related to vaccines. And you can interact with it. And if you hover on it, you'll be able to see the number of tweets, which corresponds to the size of the bubble, the latitude and longitude, and then the sentiment value. A lower sentiment is represents a more negative. Lower sentiment value represents more negative sentiment, and it's depicted by a red color, and a higher value is more positive, depicted by blue. And neutral, a lot of the tweets are neutral, which is around the yellow-green region.
So our project does have an immediate impact. For example, it's very easy to identify geographic areas that are experiencing a more negative sentiment about vaccination during a given period of time. So for example, healthcare officials can look at the data and refocus their efforts towards educating local citizens about the benefits of vaccination. And ordinary users like the general public can initiate and participate in discussions to hopefully encourage others to vaccinate in their local communities, or just gain a better overall understanding of global sentiment towards the vaccine. So for future work, we would like to continue training our neural network on more tweets and then adjust the algorithm to increase the accuracy. So our current accuracy rate is about 90%, but we would love to increase that even more. We would also consider automating a process to scrape tweets real time into a database to display live results on a map, and not just from like this past week or this past month. And we thought it would be interesting to incorporate a feature that overlays a map that displays a percentage of the local population that has received the vaccine, and then compare it to the population's overall sentiment towards the vaccine and see if there's a relationship between the two. And then we could also consider extending the map data, not just from the United States, but to the rest of the world.
Yeah, anyone have any questions?
Hey, I have a quick question. Did you look at the population compared to the volume of tweets to see if there was any, bias with small populations and high number of tweets?
Oh, no, we didn't consider that, but that would definitely be something that we should consider in the future.
Question if you're done, Charles?
Yep, I'm done.
All right. Fantastic. Great, great job. I am going to outright admit a fair bit of bias. I sit on a national COVID advisory board for the government and Morehouse School of Medicine. And this is very timely. This is a topic that I've had a few conversations on a daily basis over the last couple of months in terms of vaccine acceptance. So great job. And certainly I want to follow up with you. I would love for you to show this to some colleagues at Morehouse School of Medicine and National Institute of Health. I think that one of the questions I do want to ask is, you see that there are some areas, and the idea is that people are far more likely to tweet negative tweets. People are like, hey, I accept it, I'm good with it, and they don't tweet. So there seems to be this amplification to the negative. One, do you think that given the data and the graphic overlay, you can drill in and say what areas seem to have this echo? And this is along Charles' line as well, where, man, there's only this many people that live on that, Indian reservation. So we look at, indigenous populations. But yet there are millions and millions of tweets. They're just getting hammered. Is that something that people are trying to exploit, meaning that the disinformation? So I think the two big things there is, do you think that you'd be able to identify signal that says, hey, this has got a volume that's out of line with kind of the density? But then two, also, do you think you could extend this to identify key misinformation snippets or things like that to say what is the misguide there or the amount of misinformation? What are your thoughts on that?
Yeah, I think those are great questions. To address your first question, I think it's definitely feasible to kind of incorporate a feature that displays the ratio between the amount of tweets versus the local population, and then you can hopefully see and analyze it. Users can analyze that and then consider that into determining if it's kind of like an amplification effect for that certain area. I think that's very possible. And then for the second question, there are certain techniques that we can use. For example, when we're analyzing the tweet, we tokenize it. So we split it up into the component words, and then we can figure out like what's the most common word that's being used in a certain tweet in a certain area. So I think we can definitely try to incorporate those features and determine like what's contributing to this type of sentiment.
Very good. Excellent job. Very nice. Thank you.
Yeah, nicely done. Good job.
All right. Thank you so much, everyone. So yeah, we have
just very quickly. Are these being recorded as well? So I know that you guys have recorded your video in the Expo. Just to the moderators, are we also recording these as well?
I believe they're being recorded, but okay. I can try to double check it.
All right, no worries. Thank you, team. Great job. I really do look forward to talking to you again.
All right. Thank you so much for your
time.
Thank you.
Thank you.
All right. Yeah. So I'll remove the current team from the screen. All right. Oops. Yeah, and then we're going to have a new judge coming. So we're going to have Sriyari from Anthem. Would you mind introducing yourself?
Can you hear me?
Yes, we can hear you.
Yes. Okay. I'm working as part of Anthem as a solution architect. We are bringing a lot of data, healthcare data, to the cloud in Snowflake. That's my role right now.
All right. Thank you so much for joining us today. And we're going to bring Sotera to present their project.
Do you guys hear us? Hello?
Yes, we can. You're good.
Right. Let's share our screen really quickly. Share screen. All right. If I maximize it, can you guys still see it? Or
we're good.
Oh, okay. Cool. Sorry about that. All right.
Is the cat part of the team?
Oh, yeah. Honorary
member. I love it.
Okay, so I'm Jessica. Let's see. At Solterra, basically, we have the potential to make a really big change, but we find the most effective way to do it is through a lot of small changes based off of just individual choices made at the micro level. But anyways, so our whole project is about renewable energy, and we're using forecasting through machine learning and computational modeling to make that happen. Right, so in 2019, 80% of all energy through the US was spent in fossil fuels, and we've been warned that if we want to stop climate change in its tracks, we'll essentially need to cut all of that use of fossil fuels in half by the year of 2030. So we needed to find a way to make this happen the quickest and the easiest for basically everyone, like normal people, because we know that industry is using more renewables, but the biggest way to do that is through a lot of people making that choice. I'm sorry. Okay, so with Solterra, I feel like I already said that, but yeah, we're pretty much forecasting through machine learning, and we are basically allowing the consumer to choose the easiest way to optimize their production and consumption of renewables within their household.
All right, so by accurately predicting solar and wind harvests for each user, we can personalize each forecast to allow for optimal management of a user's specific renewable resources. So this in turn increases productivity and optimizes the efficiency for the user. It allows for prediction, so we can see forecasting whether we need to use all of our gathered resources now or save them if it may be very like dark for a solar panel is not able to collect as much light as normal, or it's cloudy, or it's not very windy, things like that. And it's personalized to your data. We take very specific from your farm or however you want to use it on a plot of land or something like that, and tailor it to your experience.
So my name is Stefan, and I'm going to be talking a lot about the modeling that we did during Hacklytics. So the idea is that given location data, weather data, and irradiance models, we can use deep learning to forecast key features that are important for energy modeling, and we are able to do it in the short term. So our deep learning model can forecast horizontal or global horizontal irradiance, temperature, and wind for 7 days into the future with a 1 hour time step interval. And basically, that's the part that we've fully implemented during the hackathon. Also on paper, we kind of figured out what we need for a solar hardware model and a wind hardware model in order to get the right calculations for power, so in kilowatt hours. And then eventually that power forecast would go to the end user. The key value being that the forecast is in the short term, and it's a high resolution at the hour time step. Now, in order to make this possible, we have implemented our own deep learning forecast model. And the way this works is that it's a fusion network. And so you have one input. So given a latitude, longitude, elevation, and a date and time, that's part of the fixed input. And then the time series input is the current day's data at each of the 24 hours of the day. So you have wind, pressure, temperature, various irradiance values, and solar sun angle values. And so I chose to represent that as one-dimensional data with channels. And so what this allows you to do is it allows you to take that current time step and the fixed data by your location and perform some operations. So for the time series data, we're doing one-dimensional convolutions. And for the fixed data, we're doing dense layers. And what that does is allows the model to learn different properties about data that varies in the day and data about the location separately. And then at the concatenation stage, it takes those two things together, and then it processes them in several more dense layers together to extract more relationships. And then at that last dense layer before the reshape, the size expands. So this is reminiscent of like a neural network or a UNet. And this allows you to forecast or generate values that are of the same or bigger shape than your input. And then essentially we can do more 1D convolutions to get our final output. And the final output based on what target thing you're looking at. So if you're looking at global horizontal irradiance, you'll get a kind of like a vector. In one dimension, you have 24 hours of the day. And in one direction, you have time steps. So 0 to 7 or 0 to 6 predicting the next 7 days. We trained this with 2.8 million parameters using a loss of mean absolute error. So that way we can see the units and it makes sense for us. And we used 150,000 samples from locations around the Atlanta area from the National Solar Model Database. And we did a 30% train test split, and we only did it for 30 epochs. And this is our results. So we were able to actually accurately forecast up to 7 days on our time steps with an average error of 18 watts per meter squared for the irradiance, 0.22 meters per second for the wind, and 0.56 degrees centigrade for the temperature, which is fairly good. For future work, there's a lot to be done. We could build spatio-temporal models using 3-dimensional convolutions instead of 1-dimensional convolutions, so stacking all those features together. Also using more past time steps will allow us to increase the accuracy. And also, if you just added up and did forecasting not on the hour time step, but on the daily time step for whoever might see that as beneficial, you can boost the accuracy a lot in that manner. I wanted to show you some actually results. So as you can see here, day 1, forecasted through the features on the top, and day 7 is on the bottom. And so you can see for wind speed, the model can actually see and predict changes 7 days in advance in one shot. So all these days at the same time. Same thing with the temperature. And same thing for the global horizontal irradiance. What's interesting is that you can also see some failure cases here. So in the global horizontal irradiance, you can see that on like the 3rd day that it gets kind of like that peak, but it doesn't realize there's going to be a dip. But on the second day, it does realize that there's a dip. So the model is learning, but it still has a little bit of improvement to keep going. We also wanted to show you some actually like gridded data. So we were able to aggregate all this data onto grids and plot in the Atlanta metro area. So on the top left, you can see temperature forecast. Bottom left, you can see wind forecast. And on the right, you can see a global horizontal radius forecast. And these are forecasting at different times in the day, but these are all, the left is like day 0, and then the right is like 7 days later. Let's see. And so, you want to talk about the impact?
Oh yeah, that's me. So through Solterra's power forecast for the wind and solar trends, we can maximize the grid efficiency and in turn save costs for the end user. And in place of fossil fuels, Solterra can entice communities to primarily depend on renewable energy. And since this is accessible and our interface is very easily to interact with, it's very simple for the user to transfer to this instead of fossil fuels.
All right.
Yeah, so my name is Gerardo Garcia Ramos, and so I did some of the numerical modeling. So this is something that would happen at the beginning when somebody is first purchasing solar panels. And so one of the things that we can do to optimize their overall efficiency long term is making sure that they optimize the angle at which the panels are installed from the very start, right? And so we'll, on the next slide, we'll look at some of the equations that were used to find the optimization. So these are just numerical equations that are dependent on the latitude of the location of where they are. And then based off of that, we also calculate some of the things such as their solar angle, their solar incidence angle, and a couple of other parameters which affect how we can optimize the angle. And so the different angles that can be chosen result in different optimizations depending on what time of the year that they have these peak power usages. And so one of the things that we can do to improve it here is give some sort of timestamp of when this specific user has high power needs, and then try and optimize the angle to match that for them as well. And so looking ahead, we're really trying to, as we stated, focus on individuals and how an individual can affect their entire community, right? So if we target individual households and we maximize their ability to rely mostly on the reusable energy rather than fossil fuels, we can allow the grid operators to minimize the amount of coal power plants that are running, right? And then they can also eventually use our own, like the same software on a grid-wide scale. So if they know that in the next 2 days there's going to be a lot of wind coming into their area and they have a big wind farm, they can ramp down the big coal power plants, which take a long time to. They're not very agile, and so they can adapt their energy asset management basically to become, like we said, mostly a renewable grid rather than a mostly fossil fuel dependent grid. And looking very long term into the future, eventually this technology could really help developing markets, developing countries where the grid infrastructure isn't quite there. If you create solar and wind energy sources at a very local level, they're very scalable, right? And so instead of having to build big, expensive coal power plants or like other forms of renewable energies like hydroelectric and nuclear, those require big investments, and so you need to have a lot of capital at the front end. Versus solar and wind, you can start small, and then as the community's needs grow, the efficiency of the model will also grow, and we can allow them to grow with their needs. And I think that, thank you for listening to our presentation. Yeah. Any questions?
Let me see if it's like.
Sorry about that. I was on mute.
Oh, you're good. Okay.
All right. Charles, Shardari, you guys got anything? There we go. Sure, Hari?
No, I don't have anything to you.
So tell me a little bit about, I think fantastic job, without a doubt. I think that being able to do it across the three, primary sources. And I do come from a wind background, so I've actually spent a lot of time developing and working on wind turbines and wind energy. So I have great interest in what you guys have done, and what you've done in such a small time is fantastic. I think one of the big applications is looking at remote communities, other areas like that, and especially in the wind fields, where either through FEMA or some sort of emergency, you have to deploy assets to get energy to them. What do you guys think? How long would it take? Let's say there's a disaster. Let's say there's a hurricane that hits part of the U.S. and takes out the power grid, and it's happened. If you were to be able to deploy portable assets, how quickly do you think that you'd be able to say, okay, this is where we would deploy it? So you had a great wind field diagram. Wind field diagrams are great, especially when placing multiple turbines. What configuration in a wind farm? How quickly would it take to, say, stand this up for an island that got hit by a hurricane that we now need to bring some power to in order to enable things like that? Some facilities.
That's a great question. So based on the model we currently have, what we can do is, and this is actually can be like both a forecasting and aggregation of historical data kind of thing. If you're interested in the output over the course of a short term, like the next week or 2 weeks or month, you can use the forecasting element of it and then aggregate those values and see where the optimal location would be based on like some of the hardware models that we kind of developed on paper. If you want to do it very simply, you can also aggregate all the historical data as well. So it really depends. I guess if you want to be more accurate, and you would use the forecasting method to see what your power output would be in the next course of a week or a month, and then go backwards from there and find the best location.
Exactly. So how long, let's say that there was a storm, an earthquake or something like that. How long do you think you'd be able to say, okay, hey, let's develop a model for that you don't have in your data set? Is this something you could do in a few days that you can say, hey, let's go, grab the historic weather data, grab the other stuff, historic data, and bring up the models that you have? And because I do look at this saying that's one of the biggest things that jumps to my mind. Application.
I think what we did was we took it and we did it for the Atlanta metro region. The only reason we did it only for the Atlanta metro region is because I didn't have enough space on my computer. And we have all the software in place, we have the model set up, we have the scripts for all the data. So if you wanted to, you could run this for any region. We use the national solar kind of model database, their data and their historical data that they have, and they have an API for current data as well. So if we wanted to, we could just take all of that and just make sure our scripts are not kind of janky and polish them a little bit, and then we could run this very quickly. Probably if you want to run just the model and get the outputs and everything's in place, you would probably be able to train in an hour and then run in less than 30 minutes and then get nice graphs out of it.
And yeah, so another thing that we have is so each user, anybody that is using the software, you can also have it feed back into the model, right? So if you know that there's going to be some sort of storm coming to the Caribbean soon, right? Instead of waiting for the storm to come and then deploying wind or solar units out into these areas, you could actually deploy wind units to the area beforehand. And then that way you can increase the fidelity of the data that you're getting into the model, and then better predict what's going to happen in the short and midterm, looking ahead, if that makes sense.
Yeah, no, absolutely, without a doubt, fantastic job. Again, I'm always stunned at what you can do in a short period of time. So great job, guys.
Thank you. Are there any more questions?
right, thank you so much, everyone. If we don't have any more questions, we can move on to our next team, which is Blinker. Yeah, so let me get Blinker on here. All right, do we have everyone from Blinker? Yes? Great. Please introduce yourself and present your amazing project.
Hi, my name is Wei Lun, and with me are my teammates Benedict and Ayun. So let me just share my screen first. Great. Can everyone see my screen? Thumbs up. Okay, great. Right. So without further ado, I'll begin my presentation. So welcome to Blinker. So Blinker is the app that we conceptualize and develop. So let me share with you what Blinker is actually all about. So right now, with much of the world in lockdown due to COVID-19, many people are actually working or studying from home, especially for college students like us. We spend so many hours in front of the screen, and it takes a toll on our bodies and our eye health because looking at the screen for so long will cause a lot of eye strain. And this can actually be alleviated if more people know about proper eye care techniques. So we decided to create Blinker. So this is a web application that can provide a visual acuity test and also remind the users to take consistent breaks to reduce your eye strain and also improve your vision in the long run. So Blinker provides users with essential eye care techniques. And in the midst of a pandemic, it is actually very important to limit the unnecessary trips to the doctor. So we wanted to include a basic eyesight tester in Blinker. So this is based on the Snellen chart. So right here, you can see you can take an eye test, and users will be asked to provide a verbal response, and this will be recorded and analyzed. So you can press the record button here, and I can actually speak something like "Hello world," or what the user is supposed to speak is actually the letters that they see here on the right. So I can press stop and play. I'm not sure whether you'll be able to hear the output on your side, but the audio is playable, and the user can actually re-record the audio if they are not satisfied with it. So once this is actually done, we can click the next button. So this generate button actually sends the audio file to a speech-to-text API. So we used Google Cloud speech-to-text for this. And this would actually transcribe the user's verbal data, and it will compare with the correct answers of what the letters are actually supposed to be. And it will compare and check how many lines of text, of letters that the user actually got correct. And this would, we actually used optician's formula to do a basic calculation of which line corresponds to how good your vision is. So if we click next here, yes, so this will actually output data. Right now, we are using a pre-recorded audio file for this. So when we tested it, we managed to read 6 lines, and the result shows that your vision is 20/30. So after this, the user can actually view the eye care tips. So this is a curation of videos from some of the best eye doctors or famous eye doctors on YouTube that can provide eye health tips and how to improve your vision. right? So a couple of technologies that we used to actually build this application was actually JavaScript and Python. We decided to integrate these two with using Flask because Python is actually more suited to implement machine learning tools, and JavaScript was to actually use an API called the Web Audio API to extract audio data from the user. And then what we did was to host it on Heroku. So this front-end JavaScript will actually deconstruct the audio data into a binary string, and it actually sends it to the backend where it is reconstructed and used as the speech-to-text input. So, and then we have some logic that is performed in the backend to determine the results. So a couple of challenges and I guess improvements that we could have made is that it's regarding the audio quality. So sometimes during the deconstruction of the audio file, some of the audio elements are not really preserved, and this causes the speech-to-text API to wrongly interpret the speech and output the wrong text. And so I think given more time, we could actually try a lossless compression of the audio data and send it over. So this will actually preserve the audio quality. And the second one is also handling wrong outputs generated by the speech-to-text API. And this is actually quite limited by the API that we use. And we believe that in the future, if perhaps we have more data, then we can train our own speech-to-text model that actually performs a transcription specifically based on the letters found in the Snellen chart, right? So hope you enjoy this app, and thank you. That is the end of my presentation. Any questions?
So this is Srihari from Anthem. This is an interesting app, not only for students, even for me, like an IT professional, I spend 12 to 14 hours in front of screen every day. So we need this one. So did you capture the results like at certain time? Because when you take from the morning, it will be very clear, your eye vision. But when end of the day, it is not that much clear, right? So did you compare from morning to evening how the results varies?
Right. So what we didn't really do anything regarding the analysis of the results. So what we actually did was to sort of we researched into a general consensus between opticians on just simply based on how many lines you can read, and that would correspond to your supposed eye health or perhaps myopia level, etc. So we did not take into consideration the time of the day or even other maybe perhaps environment factors or even other factors. Yeah. So thank you. Actually, this is a very good suggestion that we could have perhaps considered, and given more time, we definitely would have tried to implement something like that.
Thank you.
Thank you.
All right. Thank you so much for an awesome project. If we don't have any more questions, we can move on to our next team, which will be NetGain.
Nice job, guys. Nice job.
Okay, I think we are waiting for another member to join. Here we go. Yes, we have everyone from NetGain now. So people from NetGain, please introduce yourselves and present your project. Thank you.
Hello, everyone. My name is Sal. I was the back-end developer for this project. Dan, go ahead.
Yep. Hello, my name is Daniel. I am the machine learning developer for this project. Hello, I'm Matthew. I'm the front end and data collection of this project.
Russell, are you there?
Oh, hello.
Yeah, he had some.
I just had late connection. Sorry. My name is Russell. I'm the data visualizer design.
Right.
In this.
Cool. So I'd like to start off by sharing my screen for a bit of a live demo of our product as it stands. Can you guys see the website? All right. Sounds good? Okay, cool. So our product is called NetGain, which stands for Novel, Experimental, and Traditional GDP Approximation in Numbers. What our product is able to do is we've trained a machine learning model on different types of hyperparameters that could predict GDP. For example, you have traditional hyperparameters such as your manufacturing layoff rate, new orders for consumer goods and materials. Then you have your novel predictors that we've identified for this project as things that people don't traditionally use, but through our economics education, we believe might have some merit, such as changing of house permit, money stock valuation. And the third set of hyperparameters that we trained on are the experimental hyperparameters, such as changing gold value, changing business confidence. These are hyperparameters that, again, we have a feeling might be useful in predicting GDP. But for the experimental data set, we don't necessarily have hard academic backing for that. So we decided to just run it through the model and see what we can see. Now, what you're seeing here is a bit of data visualization. I won't go too far in depth into it right now. I'll leave that to my team. But what we have is the ability to select nominal GDP, a model that was trained on nominal GDP, a model that was trained to predict real GDP, and a model that was trained to predict real GDP, and then the output of the prediction was converted into nominal GDP. Okay. And we have the ability to select what we're predicting and the hyperparameters we're using. So for example, a model trained on nominal GDP, trained for traditional hyperparameters, we submit it, and we see this red line at the top of our graph. We have the ability to display the series name, the prediction, and also the date for more granular data analysts. You can also do comparison to series at the same time. And a little bit about our interactability. We're able to move around a graph. And we're also able to zoom into a graph. And I think that's as much of the overview as I'll give you for now. I'll pass it over to Matt to talk about our data collection process and our front end. Thank you. If you want to share screen, I'll stop sharing screen. Let me know.
No, keep this. It's fine. There's not much I can really show in the way of data sources and stuff like that. So for our project, out of everyone here, I am although I have my major in computer science, I minor in economics, and so I was wanting to suggest looking at GDP and the rate of GDP, because that is something that really hasn't been touched on a lot of my experience. We see a lot about information related to the stock market, but I'm very curious about how the business cycle relates to. And so we looked at 3 different ways of figuring out data. We looked at the traditional ways and stuff that's taught in my textbooks, stuff that you see as common leading indicators for GDP growth. And so, like we mentioned, that's manufacturing layoff. That's stuff that we can pretty confidently say will affect GDP, but we don't really know the direct correlation. Then we went into novel, which is more specific details. So we talked about new orders of goods and consumers and like everything with the manufacturing good orders. And however, in novel, we looked at specific like tech, consumable goods, durable goods, and how those might influence. And finally, for experimental, we looked at various things that may or may not have any influence. Like we looked at the stock price of gold as just a example that might or may not affect things. We looked at how confident are people in the market, something that would be very difficult to judge. In the past, we can now look at with a lot of data readily available to make those changes. And it allowed us to test out a couple different models and see what really affects GDP growth per quarter. And I was also in charge of front end, where the HTML and the CS works with the backend that Sal made and allows us to be able to play the data.
Yes. Go ahead, Dan. Go ahead.
Let's Russell, go ahead and talk about the charts first.
Okay, so with our data visualization, our goal was obviously to make the analysis of these variables of GDP more accessible and easy to interact with. So we use matplotlib as our library for adding these functionalities of one tooltip. Could you demonstrate that again? So like if we hover over a specific data point, we can obviously see exactly what time this is referring to and what series that is associated, like when you're displaying multiple things. So we can compare these much easily and see exact like prediction change values as in the second parameter. And matplotlib also allowed us to have this color theme that blends well with our background and makes it look very in line with everything, all the other themes on the front end. And so down below we have those selectors, as Sal was mentioning, that allowed us to display multiple sets from the different models that we were training with different hyperparameters. So as he like selects multiple things, it loads very quickly, and you can see the updates with the different colors coordinating, and there's a lot of data there. And so when it gets messy, you can obviously use the tooltips like we were mentioning to decipher through which points are from where. And with the graph, we also have the panning, the zooming. These are standard matplotlib features that makes it very easy to visualize these data points. And our extended library of MPLD3, this allows us to take these nice plots and embed it directly into a website with this SVG format that was copy-pasted HTML, basically, that was piped through the Django's templating library, language, sorry. And this allows for easy integration into the front end with, as Matt was talking about the design around the graphs. So moving on to Dan with the machine learning model.
Yes, so for the machine learning model, we used a Python library called scikit-learn, which has a library of many different machine learning models. The one we used is the linear regression model for its simplistic nature in representing this data. It is robust to outliers, and to input this data, we needed to normalize the data and to make sure that the model can interpret it. And okay, so we used a high pass filter to ensure that the high frequency data could be removed, and because of the low amount of data points we had with this project, because the data was reported by quarterly, and we took the data from 2002 to 2020. This would be needed to reduce the bias in the data. And we were able to reach about a 0.6 score in the regression R-squared score, which is pretty good, but we still have room for improvements by introducing more hyperparameters. So, yes.
Cool. So I'll talk a little bit more about the ML that we did and how it relates to our backend and then the backend itself. So currently, both the backend and the model are written in Python because we're using Django's web framework. So the potential for real-time AI training and all that is there. But unfortunately, that's too much for our current project and what we're able to do right now. This is future work that we could do. Currently, the ML model is trained in advance with these sets of hyperparameters. The results will be pickled and then sent over to our backend, which will then carefully select which data based on the results of what you're selecting here, and then send it over to the chart to be displayed. Okay. We have a whole database set up in Django to store the graph data, the graph series, and the set of hyperparameters used. Unfortunately, due to the complexity of filling these Python archive files, the backend is underutilized. So this is also future work to get that backend up and running to its full capacity. And again, I kind of touched on this a little bit in the beginning, that the potential for real-time training is there. Unfortunately, right now it would take too long to do it on like client side and how we have everything set up. But if we were to have access to a higher power server, the user could input individual hyperparameters that they want to use to train and test and do their own experimentation on predicting GDP, rather than these set hyperparameter sets that we have right now. So the potential for expansion is there. And also, right now we're only displaying GDP related to the US. That's because, as Matt has touched on a bit, this is data that is not as hard to find. It's readily available on the Federal Reserve of St. Louis website. Easy to analyze with our model. That's another form of expansion we can do, and also investigating more types of hyperparameters. So yeah, that's all we have for our initial interview. If you guys have any questions, we'll happily field them right now.
Great job, guys. This is Keith Worley. I'm going to admit some bias right off the bat. The way I got into analytics 30 years ago was econometrics, so the early days of mathematical economics. So a little bit in my wheelhouse, but you know, we used slide rules back then. You can Google what those are later. Tell me, so the part that I didn't see that, and I think you said it, but I just didn't see it in the visualization, is tell me about the predictive power of the linear regression model. The idea is that, did you test it? How accurate were you? So what is your accuracy 1 quarter out, 2 quarters out, 3 quarters out? And the idea is that what would I be exploring in terms of the predictive value of those different hyperparameters and attributes? So I get from what I read and heard you say, that's one of the powers of this, but yet I see that a lot of noise on the charts, and ultimately, you know, cut through and clarify, not, you know, display noise. Tell me a little bit about that. You guys still there? So any idea in terms of your ability or test to be able to predict? Did you back test or anything?
Yeah, I'm going to defer to Dan for that, the machine learning expert.
Yes. So for our model, we predicted the change in GDP out to 1 year out. We didn't do for 1 quarter, 2 quarters, 3 quarters. We just stayed with that. And our model was able to respond very well to nominal GDP converted with a novel data set. It was able to achieve about a 0.4 R-squared value, which is still has a lot of room for improvement.
Very good. So you are learning how tough it is to predict both its stock market and GDP. It's
yes.
Okay, very good. Thank you.
All right. Do you have any more questions? If not, we can move on to our next team.
Nice job, guys.
Yeah. Thank you so much, NetGain. It was amazing.
Thank you very much.
Thank you.
Goodbye.
All right, and I'll get the next team up. And yeah, I think we're waiting for more people from.
Yeah, my teammate's currently under the weather, catching up on some sleep. So I could just take it from here if that's okay.
Yeah, that sounds good. And also, we're a bit like running out of time, so we'll limit to like about 5 minutes per team from now on. Is that good for everyone?
Sounds good to me.
All right. Yeah.
Okay, let me share my screen. Let me share this. All right. Can everyone see that? Cool. So basically, I think we can all agree these past few weeks were pretty crazy with regards to social media and the stock market. And although it was fun for a lot of people to kind of see the little guy kicking back at the big investor, it did cause a few hedge funds to lose a lot of money, which at the end of the day meant a huge loss for a lot of retirement funds, pensions, and whatever else like people have in hedge funds. So we decided to use a little bit of sentiment analysis, some convolutional neural networks, and some JavaScript to help investors better understand the relationship between social media and the stock market. So right here, we crawled Wall Street Bets, which is a famous subreddit that's behind like all this controversial stuff. And we pulled about 10 megabytes of data from the past month or so. And after we grabbed all those posts, we did some rule-based sentimental analysis using something called Vader on each of the posts to give them a bull score or a bear score. So for some of the more positive posts, we kind of gave them like a bullish score. And some of the more scary negative posts, they had like more bearish scores. So after that, we put some more data on the posts into a convolutional neural network, including upvotes, karma, number of comments on each post. And then after that, we just use that to strengthen the scores. And then we aggregated all of those into these, basically this graph. And so this orange line here represents the bullishness of Wall Street Bets on GameStop on a specific date. And the green line is the actual price of the stock. So you can kind of see that there are some similarities. It's not a perfect relationship, but there are some similarities between the orange line, which is the bullishness or bearishness if it's negative, the bullish or bearishness of Wall Street Bets, and the actual trend lines of the stock. And so you can tell like sort of there's a peak here followed by, a peak here. So it kind of like precedes the peaks, which makes sense because people would read, Wall Street Bets posts and then make investment decisions. Wouldn't recommend that, but a lot of people do that. And, you can play around with the data. You can easily switch from stock to stock. A lot of cool stuff like that. You can see information on the stock, like our estimated control of how much retail investors own it, the danger of a short squeeze, things like that. So one particularly interesting thing is if you zoom in on a day, you can see the price of the stock on that day and the percent change in the stock. And we also pull up all the Wall Street bets posts from that day. And you can see if it's a green day like this, where there's a 20% increase, the overwhelming posts, sorry for the profanity, but the overwhelming posts are positive. But, if it's a more red day like here, you see some more negative posts, and like they have more bearish scores, which is what the red is, rather than bullish scores like these. So that's kind of how it works. You see the trend line, like this is a pretty decent trend line. Like the peaks kind of precede each other, the troughs precede each other. And you can see, these posts for different stocks. One really cool thing I found was like if I were to go to like a normal stock, like let's say Tesla, and I changed the date to more like February 1st or something, a lot of the posts are just talking about GME and then mentioning Tesla as a side, which is pretty crazy, like how laser focused like the subreddit was on particular stocks. But yeah, they said 5-minute presentations, but I'm happy to answer questions on the sentiment analysis, the neural network, whatever. Yeah.
Nice job, without a doubt. So let me ask you this: what do you think so if you were to put this out as an app or something, what do you think is the number one kind of use case that would really draw these users to this? I see a couple of different things. Oh, we can mash on this, we can mash on that. What do you think is the use case that really is sticky here that gets people to say, hey, this is great?
That's a great question. So these are like the 10 hottest stocks on the subreddit. And obviously, as we go forward, we're going to expand to more and more stocks, and scrape like more sources like Quora, et cetera, et cetera. But some interesting things we keep track of is, one, how much control retail investors have over the stock. and the danger of a short squeeze. So basically, let's say someone is an investor in GameStop or AMC, and they're not like one of these Wall Street bets guys. They're just holding it for the long term because they think it's a good. It's like because they like the stock. So when they start seeing some trend lines, like let's say, let me change the data around a little bit, but they start seeing some crazy trend lines like this, maybe then they know, okay, I shouldn't mess around with the stock. Or on the other hand, it could be used by a more risky investor, like a gambler, like myself, who sees the stock kind of going crazy on Wall Street bets and might want to buy some call contracts.
Very excellent. So it seems like there's at least one or two new metrics, wolf metrics, that you think that either retail investors or even institutional investors might look at to say, hey, is there a danger vector here of the short squeeze? Well, when I checked the wolf index, so nice job. Very nice.
Appreciate it.
All right. Thank you so much for your presentation. Next up, we have, let's see. Sorry. We're going to have COVID tracker if they're up. Yes.
Hi, can you guys hear me?
Yes, we can hear you. Yeah, please introduce yourself and present your project. Thank you.
Cool. So I'm Kwan, representing COVID Tracker, computer science student from the University of Minnesota. So this project is inspired by our common frustration among the group, which is even though we get a lot of news and sensational headlines about COVID, we don't really know what to do on a day-to-day basis, right? Is there COVID danger if you were to go out shopping today, for instance, or should I delay my trip for the weekend? So with that in mind, we built a Python notebook as a prototype for an app that we think would be useful for everyday ordinary person like us. So this is our projected display of the app. And the graphs that you see are actually generated from our analysis. So I'll go more in depth about what these graphs mean and what purposes they serve. So we believe that the four most important metric that any person in this pandemic could use is whether or not there's going to be an impending outbreak in the next 7 days, so that I'll plan my movement around it. So in order to achieve that, we need some sort of time series prediction. And that's exactly what we did. We scraped data from New York Times GitHub repository. And then we used a library developed by Facebook called the Prophet, FB Prophet, which is conventionally designed for business use. And we find it to be very fitting for this particular use case because FB Prophet design is engineered around the idea that there's going to be seasonality and there's going to be changing trend lines, and that certain days of the year you would experience outliers or like vast changes in numbers. So for instance, Thanksgiving or Black Friday could contribute to a lot of sales, but it could also contribute to a lot of COVID spread. And so we think it is a fitting model to be used for modeling the time series of COVID cases. So here we have selected one such county. So as previously mentioned, we want to focus on the regional news, not the national-wide news, so that anyone could look and see, oh, let's say I live in Atlanta, Georgia, and I want to know whether or not it is safe to go out today in Atlanta, in the county of Fulton. And so I can just type in the county name and then run the analysis, and then it would collect the data from
Quan, are you sharing a screen? Because we're not seeing anything.
Oh, I'm so sorry.
Yeah, I was gonna, okay, any minute. So yeah, your screen is not shared.
Yeah, let me catch you guys up with what I've been showing. So, I'm so sorry for the blunder. Right, so this is the screen that I was talking about. There we go. So this is the Georgia state map, and then this is our model's prediction of how likely there's going to be an increase in COVID cases in the coming week. And then this is the trend line for a specific county. So you could just type in your county, and then it will give you the information. And yeah, so as previously mentioned, this is the FB Prophet model that we're using. And what this model is quite neat because it automatically detects changes in faces. So you could see it basically automatically finds out whether or not there's a upsurge, uptick of cases, a downward trend of cases. The model seasonality, so you can tell on a weekly by weekly basis, is there going to be rise and fall in COVID cases? So if you look at this, for instance, you can tell, oh, maybe Thursday is not the best day to go out because it might be a very common days for people to go out in your particular county. So you can avoid that, and you can strategize your grocery shopping trips, for instance. So yeah, with that in mind, we were able to. So this is the time series data, but we are also interested in the geospatial data. So we scrape. Let me scroll down here. So using data available online, we were able to piece together different counties and then predict the COVID rate changes in each of those counties and try to study if there's any correlation between different counties. As it turns out, there seems to be a good amount of locality effect that we believe can be exploited to give more higher resolution data to the user. And so combining these two models, the first, the time series model, and the second, the geographical model, we were able to improve the accuracy of our final model. So here you can see that different columns refer to the different counties. And we combine counties in a single neighborhood to give us prediction about changing COVID cases in the coming week. And this is the resulting graph. So this is the county of Fulton, where Atlanta is based in, and the surrounding counties. So we can see that they are projected to have improvements in COVID cases over the coming week. And the county of Fulton especially is predicted to have little to no change in the coming week. So we're thinking if we have an app that can show the user this, they can plan what to do in the coming week on their own. Yeah. You don't have any questions?
All right. Thank you for your presentation. Do you have any questions for this project?
Kwan, this is Srihari. Just a general question. What technology is used for generating these reports?
Yeah, so the graph itself was generated using GeoPandas, using Python, and that automatically handles geospatial data. And the analytics itself is handled by Prophet, which is a library developed by Facebook for business analytics, but which we think can be very applicable in modeling COVID cases.
Thank you.
Nice job, Kwan. I know we're up against time, so I appreciate you doing that. I don't have any further questions, but very nice job.
Thank you.
Thank you so much. Then we'll have our next team up. Yeah, I think we have some more team members, but we can go ahead and start. So would you please introduce yourself and your project? Thanks.
Yeah, of course. So my name is Marilyn, and our project is called The Future of Healthcare, Telemedicine. And while my teammates join, I can briefly talk about it. Is that okay with you guys?
Very, very quickly, just an aside, I think that's you, Irene. In the interest of time, I don't know how many more presentations we have, but we're going to go into overtime. I think we need to get pretty strict about kind of timing for these because I and one other person do have something else we need to get on to. So unfortunately, we don't want to run out of time at the end. So, okay.
Yes. So from here, I see that we have 2 more teams following this. So
okay,
like less than 5 minutes per team.
Okay, no, then we're good. We should be good. I didn't know if we had 5 or 6 more.
Are we supposed to be
You just
I think. Thanks, Irene. Back to you. Sorry to interrupt. There's Sunny.
There we go. All right, is Logan
our,
here?
our last teammate should be joining very shortly.
Okay.
Get started, and I'll come in when Irene can bring them in, or whenever you're ready.
All right.
I think we can go ahead and start presenting, waiting for like one more team member to join.
Okay. Do you want to get started, Marilyn? Hello?
Go ahead and get started, guys.
All right. Marilyn, you can go.
Yeah. Yeah. I can share my screen. Yeah. All right. Can you guys see the presentation?
Yeah, we're good.
Yes, we can.
Okay. All right. So our topic is the future of healthcare for telemedicine. Okay, so the main questions that we're focusing on today are what is the relationship between health expenditure and the standard of living, and how can we relate measures of economic wealth to access and availability of healthcare? Right, do you want to continue, Sunny?
Yeah, sure. So we use data sets from the CDC and from the World Bank and many other resources, and we tried to compare the amount that a country spends on their health expenditure, and we related that with COVID-19, and we realized that there wasn't a strong correlation between the expenditure and the COVID-19 cases or tests, but there was somewhat of a correlation with deaths. And as we'll see further with our visualizations, you'll see some of the correlations and the graphs that we had.
All right, so uneven access to healthcare. So essentially, we discovered through an analysis of 2 data sets, one that showed like the number of hospitals that we have across America by zip code, and then the number of population of people per zip code. We were able to create this heat map on Tableau that basically shows the regions of no access as well as the regions where hospitals can't meet demands. So for example, the areas where the spots are like redder show that it's like a high density area where the hospitals are most likely overloaded with patients, while the areas that are greener or even white show that there are no hospitals in those locations, or there are like very few patients per hospital. So with this information, we basically determined that there are many hospitals in the urban regions that are at full capacity or near full capacity and would benefit from other ways to treat patients, including like virtual ways, such as telemedicine. And for rural places, we also discovered that through our surveys, about 2/3 of rural residents said that access to healthcare facilities can be quite difficult for them.
Okay, I knew this. So in general, we saw that the demand for hospital beds is increasing without enough increase in supply of beds. And so there are less beds and more people needing beds each consecutive year, as seen in the graph. And we expect this trend to continue with the emergence of new strains of COVID-19 and overall just the demand of healthcare services, with large parts of the country having poor access to vaccines and COVID-19 testing resources.
Right, so the quality of healthcare versus the spending. And in general, we compared average hospital ranking scores of each state to the average total and out-of-pocket expenditure of individuals. We found out that there is little correlation between total spending and quality of healthcare. However, there is a strong relationship between out-of-pocket expenditure and care received. This shows that quality healthcare is accessible unevenly and is likely dependent on several environmental factors. There are two explanations for the results of this comparison. The most obvious being that those capable of paying receive the best healthcare, but another perspective could be that insurance coverage does not directly correlate to better healthcare.
So we thought about possible solutions to address this disparity, and one solution is telemedicine. Telemedicine is pretty much the concept of you not having to go in person for a doctor's visit. You can simply do it over the phone. And there are limitations to that. For example, if you had to get a physical, you can't really get a physical over the phone. But we believe that this really helps in terms of rural areas or people that are just far away from hospitals who just don't have access to just a doctor. And another benefit of this is you can see many specialists. So at times when you have something wrong and you want to see multiple doctors for the same opinion, if you're in a place that's far away, that can be very expensive to go out to different areas and see those multiple doctors. With telemedicine, you can just call them over the phone and you can see many specialists within a matter of minutes. And we saw that with COVID-19, the use of telemedicine spiked. Before, no one really used it. And after COVID-19, they plan on using it more, but it's still not like predicted to be as common. And so we're hoping that it becomes more common so more people can have access to healthcare.
All right, so finally, though telemedicine can be a very useful tool for many populations, most Americans are either not offered the service through their healthcare provider, don't know about it, or do not have a usual place of healthcare, even during COVID-19 times. Therefore, we recommend healthcare providers to invest more resources and funding into using and marketing telemedicine so that not only more people can use it, but that they can afford it and afford healthcare in general. And additionally, for future consideration, other solutions besides telemedicine for this problem, as well as publishing the insights we found in a paper or website. Right. Thank you for your time.
I would love to show some of the visuals that we were able to create if possible. Do we have time for that?
Yeah, if it's quick.
Okay.
I'm sorry. I'm just going to butt in here for a second. So just want to acknowledge that we are past time and we do want to respect the time of our panelists. So
okay, gotcha.
Okay.
We would like to give them the opportunity. I know we have one more team queued up right now. If our panelists would like to continue for 5 more minutes until 3:15, otherwise this might have to be the end of the stream.
I think if you want to go ahead and we'll give you 2 minutes to see, because now of course we're curious to see you. So throw up your best 1 or 2. How's that?
Okay, yeah, of course. I think one of my favorites that we were able to make is I think this one that is comparing the Gini coefficient, which is income inequality, and then human development index, and then the percentage of GDP that is on healthcare expenditure. And you can see that there's like some very weak correlations when you look at one variable. We found that there's some strong like predictors if you look at both variables together. And then we were able to, well, I wanted to show one more graph. So this one is hospital rating versus like this is average hospital rating per state versus the out-of-pocket pay and the total user expenditure for healthcare in each state. And what's interesting is that there's little to no correlation between total spending, but there is a strong correlation between out-of-pocket spending and hospital rating. And I think that's quite interesting because it shows that, like, obviously the more you pay, the better healthcare you're receiving, but it means that spending more does not necessarily mean you're receiving better quality healthcare. And I think that's one place that telemedicine comes into, because it's easily accessible to everyone, and the cost should be lower because there's less, I guess, like costs involved with running the application and like meeting with the professional. And this is another heat map that I think Marilyn got a chance to explain earlier, but we're pretty proud of this one.
Very nice, without a doubt. I think that being able to visualize in more than 2 dimensions, you can see really unlocks some pattern recognition. You say, there's, the idea is a single correlation. So without a doubt, I think that visualizing things in higher dimensions is very important. I will tell you to go Google Hans Röbling. He did stuff similar to this using Gini index and things like that 20 years ago, and did not have the tools and stuff you have. So I think you've done a nice job there. So great job, guys. I think that it's a very big field, and the question is, what direction do you come at? What do you use, and how do you sort through it? In very little time, you've done a nice job.
Thank you.
Thank you.
All right, thank you so much. So if we don't have any more questions, let's quickly move on to our next team, which is clinical model.
Nice job, guys. Thanks.
Yeah, clinical model tuner. So I'll add you guys to the stream. So please introduce yourself and please go ahead and present your project.
Okay. Hi, I'm Tim, and my partner is Jason, and we'll just jump right into it because keeping in mind the time. So we've developed, or what we're calling—
Share your screen. Oh, okay.
It's showing.
Now it's running. Yeah.
Sorry. We're calling this clinical model tuner. So the purpose of this is to increase the generalizability of a neural network, especially when deploying a network for clinical decision-making tools. There are real life or death consequences that may come as a result of this. So as a clinician, if a clinician were to use models that are developed, they better be sure that it's going to work for their data. They might think that the model is validated on your data, but how about my own? So we have 2 test cases. One is an X-ray for pneumonia binary classification. Imagine that I am Dr. B from Hospital B. Hospital A has a data set that they've trained a network on for binary classification, and we want to see how it would perform on my data. So to simulate a difference in domains, we've implemented Gaussian noise and contrast shifts. So to reiterate, the image on the left is the hospital that the model was trained on or pre-trained on, and our images is on the right, where we've called it distorted. So this might be a factor of image acquisition system or imaging protocols that would cause domain changes.
Okay, so just to kind of clarify our goal again, our goal is to reduce the burden of coding and technical factor for professionals by providing an ease of use tool that allows them to adopt larger and more sophisticated models that are out there to their specific individual needs and requirements. So we created this web application where the user is able to specify parameters and able to add their own labels and label image that are required to be trained. So as you can see, that's what Timothy is doing at this point. And once you press submit, the model is being trained. It will trigger to be trained in a bit.
It takes around 30 to 45 seconds to train. So we'll just jump back into the presentation as we wait.
So some of the technologies we use for this project was PyTorch for machine learning. We use React for our front end, and Node and Express for our back end. And we use something called Zero RPC that will allow us to kind of communicate between the Node, which is a JavaScript framework, to a PyTorch, which is a machine learning framework. And in the result, we can spit out a result to our front end to actually visualize a result.
just to quickly talk about challenges, one major challenge was to finding a suitable data set that had a pre-trained model. So we found 2 data sets that were suitable for our fine-tuning purposes. So as you can see, the accuracy is 68%. This is amongst actually the lower ends of training, and we believe we can make it more consistent with fine-tuning of the hyperparameters. But the range is between 60 to 85%, and I'll just explain the graphs briefly. The left column is the original image. So this is using the pre-trained model and just inference on the same domain that the model was trained on. The middle column is our noise added or second hospital. So this would, in our case, be my data, the hospital B data, without fine tuning. And the third column is with fine tuning. And we can see sensitivity, specificity, average accuracy. And just quickly to show you an example, we've trained it on a 4-stage classification network as well for OCT classification, and also see similar results. And just showing best performing, there are times where the fine-tuned is better than original, and this might be due to slight overfitting to the specific domain, which is actually fine because we're only using it for the test case of the domain. Yeah, and are there any questions?
I guess we can go over the kind of like how the application would work.
Sure.
It's just like a web application where anyone can come in, and so either for the model you can provide a Google Drive link, or you can choose from our preset one. For our demonstration, we had a couple preset ones that we could easily just get it up and running. So there's a level, you can set the layers that would require to be trained. That meaning that all the other layers will be frozen while the last couple layers will be unfroze, and the number of epochs that would be required, and it would be for PyTorch. Apparently, we would have to require architecture and pre-processing algorithm in order to like kind of align everything to work.
Yeah, this is just a standardized testing data so that it fits the size and architecture of the model.
And as you saw, that my partner adding the images in, so you can add multiple labels into it and just drag and drop images into it to kind of add it as a classification label.
Yeah. Thank you.
Thank you.
All right. Nice job. Wow. Very interesting.
Thank you.
Charles or Shirhari, do you guys have any questions on this one? This one's pretty mind-blowing.
Yeah, this is an interesting concept.
Yeah.
I don't have any questions. Looking good. Nice job.
Okay.
Thank you.
Okay.
Charles?
No questions.
Okay. Thank you very much.
I think that I want to ask you one question. I'm not clear in my mind, without a doubt. We actually had a couple of spin-outs from Georgia Tech back in the 90s using X-rays and similar technology to automatically detect tumors and things. So this is an area that still is wide open. To be able to do this stuff. Who do you think who's the primary user of this tool? Is it people that are labeling data sets so that they can then be used in AI models? Or do you think it's actually clinicians and radiologists that are actually reading and diagnosing?
How we've utilized this is, it is known that AI has the potential to be comparable to clinicians' diagnoses. And as a diagnostic tool, there are some FDA-approved tools that are in study right now, and we think that AI really increases at least the efficiency of diagnosis. So it alleviates the burden of clinicians. So how we see it is clinicians would use this to have more confidence in models that are being deployed, so that they know it's specific to their data that they're acquiring. So it's more for the clinicians' confidence in the models that are being deployed. That's how we see it.
So you're saying, and maybe that's where it is. The idea is that a particular clinician, let's say they work in a particular field, they can actually train their own data set using AI so it helps them with their specific field of inquiry, maybe a type of cancer or other specific disease that they spend a lot of time with.
Yeah, so there's transfer learning where you train it from a different maybe a different classification problem, but what we're tackling is the fine tuning. So if I've trained something for brain tumor segmentation, and you also want to have your images segmented, but the difference in our domains of data might cause the model that I've trained to not perform as well on your data. So to ensure you that it will work well, we provide this easy to use app that clinicians can just drag and drop their own data to kind of just tweak the model a little bit, freeze a lot of the training, but tweak the last little bit just to make it specific to your own data.
Okay, very good. Very good, very good. Nice job, guys. Very, very tough and technical topic and very timely as well. Thank you.
Thank you all for your time. Sorry for running.
No, not at all. Not your. Probably our fault.
Yeah. Okay. So that was our last project. So yeah, thank you so much for coming here and like judging our amazing projects. Hope you had an amazing time too.
We did. Thank you very much, Jaden and Irene. Well done. I realize there's a lot of moving parts and we old people never make it easy. Couple of quick questions. One, is the closing ceremony now delayed? We've got a couple minutes before that. And two, I still only have.
Yes. So.
Go ahead.
Closing ceremony will be starting almost immediately after this, after we end this stream.
Okay.
Yes, and thank you again for your time, especially considering we went over.
Well, question, do we stay on here if we're speaking on it, or am I on another feed?
No, you'll receive another link.
I'll receive, okay.
New stream.
Very good. And then on the Rocket Judge thing, I still only have one team that I saw that's on my selection. Should I just mark that team and leave the rest blank?
We're currently still live, so we can talk about this either on the Discord or someone should send you a new link to the next stream.
All right.
So Jaden, we don't have enough time, right, to see all those videos in next 6 minutes to judge on those sessions, right? I have 5 projects. I only saw 2 projects in this live session. So remaining 3, there is no time to see in next 6 minutes to judge.
Right. We're currently working that out. I believe we might just be moving on without those, but I'm not sure. Please ask someone in the Discord, and we'll have a response for you very soon.
Okay. Thank you.
All right. We'll see you guys in a minute. We'll go ahead and get off this one then.
All
okay.
Right.
Thank you very much.
Nice to meet you, Srihari and Charles. Sorry we didn't get to
Nice meeting you.
All right, then I'll go ahead and end the broadcast.